Hi guys, Danny here, and welcome to part 3 of my review of factorization. In this part, I will be going over the most difficult and the most useful part of factorization, the servos. Now, the servos work like the turtles from computer craft or the drones from pneumatic craft, as in you can give them instructions and they will do certain activities for you. For example, this one here, it's obviously harvesting the sugar canes. Well, there's no sugar canes here, so it's not harvesting anything. But if I do this, you can see that it starts, okay, it's stopping now because it needs charge to work. So if you give it enough time, there you go. You can see it's harvesting the sugarcane. So like usual, I'm going to go through the manual and give examples like that one there. Okay, the servo. The servo is a mobile socket, and any tool that can be equipped on a socket can be equipped on a servo. So this one here, the one that I just showed, was a mobile accelerator. They ride on a servo rail, which was the thing that I was riding on, and they move along this rail in a particular direction, and it can point perpendicular to the direction of the motion. Servos need charge to run, that's why I had to replace the latent jar because it was out of charge. You can control them with instructions, and they can be colored. Okay, so the servo rail. The servo rail is a thin strip of metal that the servo can ride on. The servos extract power they need from the servo rail, and you can put in instructions and decorations on the servo rail, and that's very important. Okay, next is the motion. When confronted with a rail junction, the servo has a choice of which direction to go. If there is an entry control instruction, it'll try to go that way. If there is a direction pointed by the set direction instruction, it'll try to go to that direction. Normally, it prefers to go straight. Now, all this here, I'm not going to be covering it with example because I'm just going to post a link to the official documentation of factorization. It's incredibly straightforward, but you know, if people don't get it, they can go to the link and it's laid out for you. It's very simple. So the basics are, it'll try to go in a straight line, and if there isn't a straight line to go, it'll try to recreate the motion from before. If it can't go straight, then it'll try to go up relative to the servo. Failing that, it'll randomly choose left or right or down. It avoids going through the forbidden entry control, so it's just this, but a negative. And finally, it won't go backwards unless there is a dead end. Also, servos won't enter a rails if they have conflicting colors. So this one here, just replace the latent jar. It's using a lot of charge. Okay, give it some time. The servo, as you saw there, was not going through this path because there is a forbidden entry control here. But what I can do is right click with the logic matrix programmer, so now it's a positive entry control. So now what should happen is the servo can actually go this direction as well. So we should see that as soon as the servo starts moving. Okay, here we go. There we go, the servo went this direction. And it'll keep going straight there until it reaches this point here with the set direction that's pointing this way. So then it goes this way again and back that way. Notice how it's pointing this way because there is a positive entry control there. So there we go. So what I can do is right click with the LMP and put it to the negative forbidden entry control. So this should stop it from going this direction, and there you go. It went right instead. So next is the motion instruction. I already covered some of these guys. For example, the set direction. It tells the servo to move in a particular direction at the earliest possible opportunity. So when it passes over it, it will go into that direction. So over here, because this guy's here, instead of going down, it's just going back this way. I could change it, so I could make it go back to, say, no, that's up this way. And the servo should follow. There you go. And because there's a dead end here, it can't go anywhere else, so it's going back. And then it's getting stuck there because the direction is telling it to go down. So move it to that direction. Okay, then it stopped. Now the thing with all of the instructions is that if you give it a redstone signal, they will be deactivated. Okay, so the next one is the point top. This rotates the servo on the rail so that the servo socket point in that direction. I have that here, so I'm just going to place that like that. Just right click. Now the top is pointing downwards, so that should change the direction downwards. I'm going to point it to this direction. Now this should be a bit difficult for the servo. Let's see what happens. Okay, it fails because the servo can't point in that direction because the rails are there. Can't do that direction either. This one points this way, so this should work. There you go. One more time. Okay, now it's pointing to the sugarcane again, so this should work one more time. Okay, there you go. And to remove the instructions, all you need to do is shift right click, and there you go. Okay. The next one is the spin. The spin just rotates the servo clockwise or counterclockwise. So I have the spin here. Just gonna place that there. Okay, so there we go. It's spun downwards. Right click that. Now it's pointing to a different direction. And there we go. It pointed back, and then it pointed back because it passed over it twice. But if it just passes over it once, let me see this. Okay. What I can do is if I put the spin here and let it pass just once, and then remove it before it passes through it again, it should remain in that direction. So I'm just going to place this one again. Okay, it's out of charge. This uses up its charge really quickly. There we go. Okay, if it passes through that, it'll change direction one more time. Okay, remove that. And now it's stuck facing outwards. Next we have the set speed. This just sets the servo speed, and right now it's just going in its default speed. And I can increase the speed, but it will take more charge. So here we go. This is normal speed. Okay, I can make it go fast. Here we go. I can also make it go faster. And the slowest would be really slow. There we go. Slow, I'm just going to put it back to normal. Oops, so now that won't work. Okay, that should be normal, and there we go. Okay, so the last instruction is just the trap. This serves the servo when it passes over it. And when the rail receives the red zone signal, the servo will continue moving. And like all of the instructions that I just went through, if you right click with the servo, the instruction will be executed immediately. And if the servo is clicked on with the trap instruction while it's already stopped, it will start moving again. So basically what that means is if I place the trap here, it should stop while it passes over it, and then I can just right click, and then it will start again. Not shift right click, sorry, it's just right click. And then I can just shift right click with the LMP, it will move. Alternatively, what I can do is I can just right click with the instructions themselves on the servo, and it will do it. So one more time. There we go. If I was in survival, I would be damaged when that passes beside me. I can also right click with the trap, or in fact all of the instructions, and it will be executed immediately like I just showed there. Okay, next we move on to the really difficult thing, the servo memory. Each servo has two lists of memory that you can see when you have the LMP in your hand. The left stack will hold values, and the instructions will modify the left stack. The right stack will hold the instructions. The subroutine instructions will add other instructions to the stack. I'll explain all this in the next one. And the instructions will be popped from this stack and executed until the stack is empty. So with the LMP in my hand, you should be able to see the left stack and the right stack there. There's nothing there, as in there are no instructions there. But for the purposes of the example, I'm going to be using this line here. So you can see various instructions that I have placed here. So the integer 1, sum, duplicate, and sum one more time. And there is the servo. You can see the left stack and the right stack there. On the left stack, you can just see the number 8, and the right stack is empty, so it doesn't have any instructions. Okay, moving on to the subroutine, which is the most important part of using the servo. The instructions will tell the servo to execute other instructions one after the other, that is the subroutine. But first, instructions must be loaded into the subroutine. So you start off by laying out on a powered servo rail the instruction that you want for the subroutine. So this is the instructions that I want. First, the number 1 again, etc., etc. At the beginning, you'll leave the first extra rail blank, and on the second rail, you will put in the entry action instructions. You will set it to read mode by right-clicking it with an LMP. So I'm going to do that now. So this way is blank and entry action there. It's in execute immediately. I'm going to right-click and put it to the read to IO stack as it's said in the instructions. And then after that, in the very end, I'm going to place the trap instruction, and before that, I'm going to put in the entry action, but put it into execute immediately. So go way over here, destroy that one. Okay, there is the trap, and before that, I'm going to place the execute immediately. Okay, and place the servo at the beginning on the blank rail, and it should read the instructions between the entry action and then stop. And then you just shift right click the servo with an empty instruction group, and you'll write the instructions into the subroutine, which is this one here. So as you can see, this one is empty, but I have one that has a subroutine already, and all that will do is it'll place the number 1 and the number 1, and then it'll sum it. So let me see if I just place the servo here. I'll check if this has enough charge, and it does. So here we go. Place this guy down and have the logic matrix programmer in my hand. Goes over the 1, 1, sum, duplicate sum, and okay, now it's stopped. Now all I need to do is shift right click, and there you go, the subroutine got written down on the subroutine item. So now all I need to do is find a place that's empty, here we go, and then right click with the subroutine like so. Okay, and you can see all the instruction there. I'll just throw down a trap here so the servo stops. And if I place down a servo, all it'll do is it'll go over the subroutine. Okay, and then it activated it. So here we go. In this one, the subroutine was supposed to give the number 8, and the servo went over it, and it got the number 8. So that was pretty simple. Okay, one more time what I did was, first of all, I had the entry action. You need 2 entry actions for this to work. The first entry action was placed on the read mode, and the read mode will add the instructions onto the servo itself. But say I had the write, this will do something else. In fact, I should show what the write does. What the write does is actually pretty cool. So if I remove that, if I go to entry action there, place it into the write mode, what it will do is it will get the instructions, okay, say for example these instructions, and it will write them on the servo itself. So here we go, place the servo down, it will go over that guy. Okay, there we go, it just placed an integer. The integer that it placed was the number 8. As you can see, the number 8 isn't there anymore. Passes over that, passes over that again, then places the 8, and then it places the other 8. But let me do it with something that you guys can see. So the entry action is still there. Move the subroutine. All I'm going to do is get the integer that gives a number 1. So just a normal integer. Place it down, as you can see, number 1. Throw down a servo. This will pass the servo, get the number 1. And in write mode, it'll just place down the number 1 again. So that's pretty simple. That's what it does in the write mode. In the ignore instruction mode, it'll just ignore the instructions. So if I had a stop there, a trap there, it will just ignore it. So here we go. Okay, and it just ignores the stop. Okay, and finally we're back on the execute immediately. That just executes the instructions that you give it immediately. Okay, now I'm going to show you guys what the execute immediately will do. So if I place the servo down, it'll go over the execute immediately, get the 1, pass over the sum, and got the number 2. However, if this was in the read to stack, it will go over it. So here we go, go over the 1, it'll go over the 1 again, and it'll go over the sum, and it'll actually say sum. Oops, that wasn't read only, so that actually read it as trap. So what you need to do is place the entry action. Okay, get it out of the way, put the entry action there, put it to execute immediately, and then place the trap. So the execute immediately will stop the writing on the servo. So here we go. Goes over the servo, writes it into instructions, 1, 1, sum, executes it, and then it stops. And then all you need to do is get a subroutine. This one is already full. Shift right click, and there you go. The subroutine is placed down, so the subroutine will just give 1 and 1 again, and then it'll add it up. So that is what the execute immediately versus the read to will do. Okay, here we have some other examples that should be pretty simple. In fact, this is close to the one that I just did. This is the multiply by 2. So entry action, read to stack. This will just start reading the instructions and placing it on the left stack. Push integer 1. This will give the integer 1. Push integer 1 again. This will give another number 1. Sum. And because this is in the read to, this will say sum instead of executing it immediately. And then it'll give the product. And then the second execute immediately entry action will stop the writing, and then the trap, which will stop it. Shift right click with the subroutine, and it will record the multiply by 2. This one is the example that I had there. So pushes the 1, pushes the 1. The sum, duplicate sum, trap, and the shift right click, it will write it down. The subroutines basically allow you to pre-program instructions that you can place as you want. So let's see, I have a couple of subroutines here, and all they will do is give the number 2, so the number 2 there, number 2 there, number 2 there, number 2 there, and place down a trap here, so it'll stop. So now when the servo passes over them, it should give the number 2, number 2, number 2, number 2, and then stop. So there you go, you can just get the instructions, and you can just place them as you want and tell the servo to do whatever you want. Okay, next we move on to the value instructions. With this you can basically use the servo like a calculator and get different values, as you saw me getting the number 8 and then the number 2. And then you can use that to perform several things. I'll give one specific example later on. It's actually pretty cool. So here we go, the different instructions that you can use to get the values. So the first one is a compare. It compares two values and then it compares them. This one is kind of hazy from the book, so I'll give you the example on the servo itself. So what I'm going to compare is the number 1 and the number 2. This isn't strictly the number 2, but it counts as the number 2 because what the subroutine does is that it gets the number 1 and then it gets the number 1 again, and then it adds them together. And when the servo passes it, it will give the number 2. So here we go. Let me set this back to equals to, so we start off from something balanced. The blue line that you see there will tell you what symbol it is. For the equals to sign, it's pretty simple, but for later on, you will understand what I'm talking about. So I throw down the servo. Okay, it goes over the number 2, goes over the number 1, goes over the equals to, and it gives me back false because 2 is not equals to 1. So that's fine. Let's go to the next one, and the next one is not equals to. So the servo goes over the number 2, goes over the number 1, goes over the is not equal to instructions, and it gets me back true because that is true. Okay, so the next one is this. Now I'll tell you exactly what sign it is as soon as the servo tells me. So here we go, you guys could probably guess. 2, 1, the sign, we get a false. So what does that mean? Basically, the servo acted as if the symbol was here, so it calculated 1 is greater or equals to 2, and it gave me back false because that isn't true. You can see the yellow line there, so that is greater or equals to. I right click one more time and it's just greater than. Okay, try one more time. So this would be 1 is greater than 2 because 1 is higher in the list. So gives me false, and that is right. Okay, so this one. So now act as if the symbol is in the middle of there, so it would be 1 is less than 2. So we can guess what the answer is going to be. 2, 1, boom, true. Because like I said, it acts as if the symbol is in the middle of these two numbers. So here we go. Let me change this to the next one. So there we go, we got it true again. And back to equals to, and we know that isn't true, but if I remove that, place the 1 there. There we go. Threw that down. what should happen is it gets a number 1, goes over the equals to, and it's true, and it gives me back the true. Now you can use these results to do various things, which I will show later on. Okay, maybe you're asking, what if it's not going to the left? What if it's going to the right? Well, the servo will naturally try to go to the left. And if it can't, well, it'll work the exact same way. So there we go, 2, 1 is false. So let's go to somewhere else. Let's go to this symbol. So this would be greater than or equals to. So let's see what happens here. Servo goes, oops, not there, over there. So here we go. Goes over there, so 2, 1, and gives a false. Because what happens is the number that's on the top when it finally calculates it, so here we go. Oops, not there, there. Okay, so 2 is lower down than 1, as you can see there. Gives a false because it counts as if the number higher is first. So it'll be the number 1 is on the left because it's higher on the list, and then it's the sign, so that's greater or equals to, and then finally the number 2, which is lower down. So let us see that one more time. Just here. Okay, so like I said, the 2 is lower down than the 1, so it counts as if 1 was on the left, and then the greater than or equals to sign, and then the number 2, which is lower down, gives the answer false. Basically, the higher number is on the left, and the lower number is on the right, and the sign is in the middle. Okay, if you're still with me, the rest of the instructions should be pretty simple. The number 1 just pushes the instructions 1, 0, or -1. Basically, you right click with the logic matrix programmer and it'll cycle through them. So it's 1 now, 0, and then -1, and then back to 1. And the boolean either pushes a true or a false. So what I need to do is get the boolean. So it's this one here. There we go. And if I place down the boolean, it's on true, right click, and now it's false, right click, and it's back to true, shift right click, and it is removed. The sum pops 2 integers and pushes their sum, so it'll work exactly the same way as the compare. The higher number goes on the left, symbol in the middle, and the one after that is on the right. So here we go. The first item popped goes to the left side, the second item on the right side, and the instruction, the symbol or the sign, is in the middle. So the sum would be 1 plus 2 equals 3. The product works the exact same way. The drop removes a value from the stack. So say I had one here. I'll remove the trap. Okay, here we go. Throw down the servo there. Gets the number 1, goes over the drop, so it drops a value and then goes to the 1 again. So which value does it drop? Let's see right now. So I'll change that to 0. Goes over the 1, goes over the 0, goes over the drop, and there we go. So what does it drop? It drops the value that is the highest. So the last number to be added is the first one to go. So let's see that one more time. 1, which is lower down, 0, which is higher up, and the drop removes the 0, which is the newest one. So the last one to join the list is the first one to leave when you use the drop instruction. And finally, the duplication, which just duplicates the value you got, so it pushes a copy of the top value of the stack and adds it again. You saw me use that when I was giving the example of the subroutine here, so it was right there. So let's see that one more time. So I throw down a servo. I'll put this to execute immediately. No, I'll just remove that actually. Okay, so let me throw down a servo. Gets the number 1 and the 1 and sums it up, so it's 2. Duplicates it, so it's 2 and 2. Adds them together again, so it's 4 and 4 when it goes over the duplicate, and then it adds them again for the last time. And we get an 8. So let's see that one more time really quickly. I won't be going over the instructions, but you should be able to see it. There we go. Okay, moving on to the computation instruction, which should be fairly simple if you've been following me so far. First we have the jump instruction, which comes in two sizes. First we have the question mark, which pops a boolean from the stack, and if it's true, then the next instruction is jumped over. So say on the left I have 1 1 true 1 1, then because it finds a true, it jumps over the next instruction. And then we have the unconditional skip, which doesn't care what the next value is, so it just skips the next one regardless. But if the next server rail is empty, then there will be no effect. So I have the setup here, so let me go to jump next. So what this will do is it will go over the boolean. Because it has a true, it'll go to the skip, and it'll skip the first one. And if I go put this to the unconditional skip and remove the boolean, now because the unconditional skip doesn't care what value it is, it moves the next one and then it'll stop. Okay, but say I change from the true boolean to just a number 1, because let's just say it's working with ones and zeros. Well, it doesn't work that way. So let me put that back there. It goes over the 1, it goes over the skip, but because it's not a true boolean, it doesn't skip over to the next one. But say I put this to the unconditional skip, well then it'll work. Well then it'll work again, because the unconditional skip doesn't care what value that is. Skips over the next one, goes to the one after. Take that out, put it to true, but set it to false, and it should be the same thing. So here we go, false, it's over, and then it stops. Also, like everything so far, it is the highest instruction on the list that is popped. So here we go, if I put down a servo there, we get a true, then we get a false, then we get a skip, and then it stops because the one that was popped wasn't true, because the one highest was the false. Let me put this down again, just in case it isn't confusing. So true there, but false is higher, and the false is what gets popped, and because it isn't true, well, the next one isn't skipped. But say I reverse this, so that's true, and that's the one that's false. Placed it down. False is lower down, true is higher up, true gets popped, and the instruction gets activated. So the next one is the entry action, which I've explained in great detail, but I'm going to go over it one more time. The entry action controls what the servo does when it runs over the instruction. So the first setting is the execute immediately, and the servo will execute the instructions when it runs over it, and this is the default behavior of the servo. The next one is the read to stack. When the servo hits an instruction, it will be copied over to the IO stack. So in this stack, say it runs over a sum, then instead of just adding it up like it does in the execute immediately one, it'll say sum. Then you can just shift right click to get it into a subroutine item. And the next one is the write from IO stack. So when the servo enters a new tile, the value will be popped from the IO stack and written onto the tile. I showed this one as well. So basically, if you had the number 1 1 1, and if it's in the write from IO stack, basically it will put down the 3 1s in the servo rail as it passes over them. And then we have the ignore, and that just makes it ignore all of the instructions. Okay, we're nearly done. The next one is the interaction instructions. This one is as important as the subroutines because this controls how you use the tools that you place in the servos. So the redstone pulse causes a redstone pulse to be emitted from the servo rail when the servo passes over it. This can cause nearby instructions to be temporarily disabled because, like I said, a redstone signal will disable the instructions. Okay, next we have the socket signal. The socket signal sends a redstone signal not to the world like the redstone pulse does, but rather to the socket tool itself that is attached to the servo. And it has 3 modes. It has the socket pulse, the socket will receive a brief redstone signal. The socket powered, the socket will receive a constant on signal, so that's just like flicking the lever on the on position. And finally we have the socket unpowered, and this will receive a constant off signal, so that's just as if the lever was off. Okay, I have this little setup here to show the examples with the redstone instructions. But before that, I should make it clear something about the instructions. Once you make them, for example, the redstone pulse one with the different items, and like always, the LMP isn't used up. you can just right click on the servo to place it down, and as you see, the item itself isn't used up, the instruction is just printed on the rail. Then you can shift right click to remove the instruction, but as you can see, the item is still in your hand and it won't be used up, and you can use it as many times as you want. So that's what I wanted to get clear. So let me go back to creative and talk about this little setup here. So I have the little redstone pulse thing here which interacts with the world, so it should give a redstone signal, and you guys should see which one of these lamps it turns on with the redstone signal to see how big the range is. It's very small. You should be able to guess which one it activates. And I have the other one here with the socket signal placed to socket pulse, so we'll just give one pulse. And I have this little setup here with the hoppers with some ores in it. Hopefully the ores will be placed inside of the servo. We'll see if it works. So here we go. I'm just going to right click with the instruction, the trap one. Remember, you can just right click with the instruction and it will be activated right away. It will be performed right away. So here we go. I do that. Okay, the gold ore got placed in. It just activated those two ones, and when it passes over the pulse, it activates once and then it stops. As you can see, it didn't keep placing down the redstone ore. That's because the socket signal to the pulse setting only pulses once when it passes over it, and it places down one of the gold ore. So what I'm going to do is hit the trap one more time. We'll go over all that. I'm just going to have to remove all these instructions. So here we go. Remove all these guys and go. Do this. Okay, never mind the excess values. All the 2's don't matter with what it's doing now. So it's going over that, passes the lamps again, activates just those two, goes there, and then it can't place down the gold ore because there's already something there. So let's see that one more time. And the whole time the servo should be getting a little bit of the ore because of the hopper. And there we go. And there we go again. But say I had this to socket powered. Let's see what happens now. Okay, the exact same thing. Because even though it's on socket powered, because the servo passes it just once, it acts as if there is a pulse. And finally the unpowered, which just doesn't do anything at all. So there you go. Nothing happens. Okay. Okay, moving on to the last interaction instruction, which is the item shifter control. The item shifter control controls the item shifter, and it changes the setting, and it will use everything that I've used so far. So if you remember the item shifter, what it does is it acts like a advanced hopper, and you can specify different amounts, you can put it to different settings, things like that. Well, imagine everything that I've used so far in this. So the item shifter control has various functions that you can swap between with the LMP. It has the set transfer limit, and then it reads an integer. So say you had an integer with the number 8 because of the sum that I did. So you know the subroutine that gives the number 8. So say it reads that, and then it will set the transfer limit to 8. And then say I had the same subroutine that gives you the number 8 and set it before the set target slot. This reads an integer, so if it reads the integer again, it will place it in the 8th slot. Well, the 9th slot technically, because the number 0 is the first slot. And if the value is -1, then the shifter would target any slot. And finally, the probe. The probe counts how many items in the inventory match the target inventory, and then it pushes an integer. If there was no inventory, then it pushes -1. If the item shifter had a target slot set, but that target slot was out of range of the inventory, then it pushes a -1. And if the servo is holding no item, then it will count all of the items in the inventory. Okay, like I said, this one uses everything that I've used so far, so I will be using everything. Okay, I'm going to flick through all of the different modes of the item shifter control, and you'll probably guess what it does. So here we go, import item. This changes the flow direction from, say, if it was export, it'll change it to import. Set transfer limit, this will read the value and set the transfer limit accordingly. Set target slot, exactly the same. Stream transfer, exactly the same. Pulse transfer, exact. This will change the different settings. Sum, probe, and this will give the value. So here we go. Let's go to export items, and at the moment it's in import. And what the export from back will do is just throw in a chest there, just for the lols. Here we go. Okay, so this is in the, whoops, this started accidentally. I'll set it to import, and if I let this go, it should go over that one, and if I stop it, let's see one more time, it's on export mode. Let's try that one more time and put it to import items. So you guys probably know what happens. It's on export now. So when it passes over that, it will be in import mode. Okay, let's move on to the next setting. So right click again, and it's on set transfer limit. So let's see what the transfer limit now is. It's on 64. So let's see what happens if this passes. So hit with the trap, goes over the 2, and let's see, the 2 is used up, so you could probably guess what happens. The amount was set to 2. Okay, now it's on set target slot, and the target slot at the moment is any. Okay, passes over the value, and now we can probably guess what happens. Target slot is put to 2. Okay, so the next setting, which is stream transfer. So let's see, it's on pulse sum amount. So when it passes, okay, here we go. It will be in stream single item, pulse transfer exact. Here we go. Now it's on pulse exact item, pulse transfer sum, and then finally probe. Here we go. Let's see what value it gets. -1. So what does -1 mean? Let's check. Okay, so it counted how many items were in the inventory, and because there was no inventory, it pushed a -1. Okay, so the last setting, probe. The probe counts how many items are in the inventory beside it, and then it pushes an integer. So if there is no inventory beside it, then it pushes a -1. If the item shifter has a target slot set, but that target slot was out of range, then it pushes a -1. And finally, if the servo is holding no item, then it will count all of the items in the inventory. What that means is, well, as you can see, it's giving the number 1 at the moment. That's because in this chest, there's this one sculpture here. The second chest is all this here. So if I remove this sculpture now, this should give 0, and it does. If I remove this chest, it should give -1, and it does. If I put this chest back, okay, here we go, gives a 0 again. So what I'm going to do is put this leather here, and it gives the number 60. Okay, so what I'm going to do is I'm going to change the setting. So I'm going to go from export to import. So what's going to happen is that it's going to take the leather. Okay, so it took up all the leather, and now it's counting only the leather. So there we go. It's counting only the leather because there is leather in the servo and there's leather in the chest, and those are the same item. As it says here, if the servo is holding no item, then it'll count all the items. As it says here, it counts how many items in inventory match the target inventory, and because there's leather in the servo, it counts only the leather. But say I change the setting to export from back. So this has no leather, so give it a second. Okay, now you see the value changed to 96 because it's counting all of these items. So now you can probably imagine what you can do with the values. Well, say I didn't have these drop instructions here and this continued on forever and ever, and say I had one of these compare once instruction somewhere along the rails that says that if there are less than 90 items in the inventory, there's 96 at the moment, you go on and you can take items out of various chests and barrels and bring them back and put it in this chest here, because I had another one of these item shifter control guys that switches it from export to import, and then it goes back there, and when it has exactly 96 items, the compare guy would give a true boolean value, and when it gets a true boolean value, because the next instruction is jump, it jumps to stop and it continues on and does various other things. So as you can see, if you compare everything so far, you can do so many things with servos alone. You can create all of these in systems. In fact, all the systems that you can create are in the project. You can have a cobble generator. You can have, say, a automatic servo sorting system with the little theoretical function that I mentioned there. You can do all of these things and so many more with the instructions and the servos. Okay, it's slowing down a bit now. I'm assuming it's going to run out of charge. Probably has. Let's see. Yep, nearly completely out. And with that, I think I've covered everything from the servos to the machines and everything in between. Like I said, I might do a little mini-series where I complete all of these projects from the Factorization with all of the items from Factorization. The link is in the description, and the little helpful proper official documentation is also in the instruction. If you like the video, please give a like and subscribe for more Minecraft videos. Thanks for watching, guys.